This is an AS Further Statistics 2 question on the cumulative distribution function, or the CDF. The continuous random variable x has cumulative distribution function CDF f of x equal to 0 when x is less than 3, c minus 4.5 x to the power n when x is greater than or equal to 3 and less than or equal to 9, and 1 when x is greater than 9. Where c is a positive constant and n is an integer. Part A, showing all stages of your working, find the value of c and the value of n. Now what we'll do is we'll start with the fact that f of 3, so this small value here, is going to equal to 0, cumulative probability of 0, and f of 9, the largest value of x, is going to equal to 1. So we can use that to form some equations and then use those equations hopefully to solve simultaneously. Right, so let's start with the first one. F of 3 is equal to 0. Right, so we substitute 3 into here and make it equal to 0. So c minus 4.5 x, which is 3, to the power n is equal to 0. And the other equation we're going to solve using the f of 9 is equal to 1. So c minus 4.5 times by 9 to the power n is equal to 1. So from the first equation, I'll make c the subject because I want to eliminate c. I could eliminate x. c will be equal to 4.5 times 3 to the power n. Substituting this into the second equation, what we'll get is 4.5 times by 3 to the power n minus 4.5 times by 9 to the power n is equal to 1. Now I can actually make this a quadratic if I write this as 3 squared to the power n and times both sides by -1. So I've got 4.5 times 3 squared to the power n, and then minus 4.5 times by 3 to the power n plus 1 is equal to 0. So there's my quadratic. Now if I swap over the 2 and the n, which I can do because you're just going to be multiplying, you might see the quadratic a little bit more clearly like this, and put that in brackets like this. And what I'm going to do now is I'm going to let y equal to 3 to the power n, and then over here let's write down what quadratic that gives you. So that'd be 4.5 y squared minus 4.5 y plus 1 is equal to 0. I'll solve for y. So y is 2/3, or y is 1/3. Remember, that's what 3 to the power n is. So I've now got 3 to the power n is 2/3, and I've also got 3 to the power n is 1/3. So we can solve these by using logs. So log to the base 3 of 2/3 will give me this value of n. So this doesn't give us a whole number, but we get negative 0.369 and so on. And then for this one, if we do log to the base 3 of 1/3, that gives us -1. Now if we have a look back at the question, n is an integer, so we're going to reject that one, and so it can only be that n is -1. And now just substitute this value of n into one of my equations. I'll just pick the first one because it's the easiest one, or the one that looks the easiest. So c minus 4.5 times by 3 to the power -1 is equal to 0. So c is going to equal 4.5 times 3 to the power -1. That's 1/3 basically. So c is 3/2, which is 1.5. So let's just highlight that. C is 1.5 and N is -1. And part B, find the lower quartile of X. This is when our CDF is going to be equal to 0.25. We've got a cumulative probability of a quarter to get us to the lower quartile. And so we'll take this with the values that we've worked out. So 1.5, that's C, minus 4.5 times by X. That's the value we're trying to find, to the value of -1 is equal to 0.25. So we're basically just solving this for X. So let's subtract 1.5 from both sides. So -4.5 x to the power -1 is -1.25. We can get rid of the negatives from both sides or divide both sides by -4.5. So we'll get x to the power -1 is equal to 5/18. So that means that x is basically equal to 18/5. Or you can give that as 3.6.